Welcome to Mitchell Maths. In this video we are going to have a look at the equation of a line. If you have an equation of a straight line, you can always express it in the form of y equals mx plus c. And when we express it in this form, m stands for the gradient and y stands for the y-intercept. And what we mean by this is, let's say we have a graph, y and x, and we have a straight line. The gradient means how steep is the line. A graph with a very steep gradient has a high gradient, whereas a graph with a very shallow line will have a much lower gradient. Also, if the line slopes downwards like this, then the gradient will be negative. The y-intercept means where does the line pass the y-axis. So this can be found if you've got a picture of the graph. You can just look at where it crosses the y-axis, and we're also going to have a look at other ways of determining that when we look at the equation and when we have like points which a line passes through. Now, in this first question, we need to find the gradient and y-intercept from the following lines. What we're going to do is we're going to look at them. We're going to see what is m, that's a gradient, and what is c. For the first one, y equals 5x minus 8. Well, I can see the number before the x is 5. Therefore, the gradient, I'll just put g, is equal to 5. For the y-intercept, which is c, we can see that it's minus 8. So I'll just put yi for y-intercept equals minus 8. Sometimes they will ask you to write it as coordinates, and if they ask you to write it as coordinates, well, we always know that the x is 0 at this point on the y-axis. Therefore, the coordinate would be 0 minus 8, if they asked us to give it in coordinates. Let's look at question B. So y is equal to x over 2 plus 5. Here, the x has been divided by 2, or same as multiplying it by a half. Therefore, the gradient is a half. And the y-intercept is just the number here on its own, which is 5. And again, you could write it as coordinates if you wanted to as 0, 5. Let's have a look at C. Y equals 9 minus 4x. The number and x have been written in a different order, but it's still the same thing because it doesn't matter which order you write them in. The number before the x is always the gradient, and the number on its own is always going to be the y-intercept as long as it's just y equals. Therefore, the gradient in this case is minus 4. Don't forget to put the sign, is very, very important. And the y-intercept is 9. And in part D, y equals 2x minus 9 over 5. It's best to sort of treat them as separate, the number before the x and the y-intercept. Therefore, I'm just going to write it y equals 2x over 5 minus 9 over 5. And when we look at it like that, we can see that the gradient is 2/5. And that the y-intercept is minus 9/5. So we're looking at on this page, we're looking at y equals mx plus c. M is a gradient, which means how steep is the graph. And we've been looking for the y-intercept, which is where does the line pass the y-axis. Now we're going to have a look at some more complicated ones. If you look at these questions where we're trying to find the same thing, we're trying to find the gradient and y-intercept, but they're not given in the form y equals mx plus c. But what we do know is that any straight line can be expressed in that form. So the next thing you're going to do here is you're going to rearrange these equations in order to get y equals mx plus c. Basically, what you're doing is you're just making y the subject. Let's have a look at the first one, part A. Well, I need to get the 2x onto the other side. How can I do that? Well, it's add 2x. Opposite of adding is subtracting. So I'm going to minus 2x from both sides. 3y equals minus 2x plus 7. The next thing I'm going to do is I need to get rid of that 3. Well, when it's written as 3y, that means 3 multiplied by y. What's the opposite of multiplication? Well, it's division. Therefore, I'm going to need to divide every term by 3. And if you're a bit stuck on how you can rearrange equations, there's a video, lots of videos on that on YouTube. Keep that minus in, plus 7 over 3. Now you'll notice I've divided them each separately. It's just, the reason I do that is because it's easier to determine which is a gradient and which is a y-intercept. And looking at this equation, what we can see is the gradient is minus 2/3. So g is equal to minus 2/3. And the y-intercept is equal to 7 over 3. Right, on to part B. This one's, we've got 2y plus 5 over 3 equals x. Well, first of all, I'm going to want to get rid of the fraction, so I need to get rid of this thing on the bottom. Well, fractions mean the top divided by the bottom. The opposite of division is multiplication. Therefore, I'm going to need to multiply both sides by 3. I get 2y plus 5 equals 3x. Next thing, I'm going to try and get rid of this 5. Well, it's add 5. I'm going to need to subtract 5 from both sides, which will give me 2y equals 3x minus 5. And finally, I've got 2y. Well, to get rid of that 2, I need to divide by 2. So I'm going to divide every term by 2, which will give me y equals 3 over 2x minus 5 over 2. You don't have to write them as fractions. You could write them as decimals. I'm just going to leave them as fractions for this, but either way is correct. Right, now I'm going to look at what's the number before the x. That's going to be 3 over 2, so the gradient is equal to 3 over 2, or 1.5. The y-intercept is equal to this term here, which is minus 5 over 2, or minus 2.5. And that's how to find the gradient of y-intercept, even when the equation's not given in the form y equals mx plus c. You just have to rearrange it first, and then once you got it in the form y equals mx plus c, you can see what the gradient is, what's equal to m, and what's equal to c. Sometimes you will be given graphs. Here we're being given a graph of line A and line B. And what we've been asked to do is we've been asked to find the equation of those lines. Now what I notice immediately is that line B is sloping downwards. And because it's sloping downwards rather than upwards, that means the gradient's going to be negative. I'm going to find the equation of line A first. I know what part C is because I can see where it's past the y-intercept here. So the C for line A is going to be equal to, C will equal 10. And to find the gradient, well, the gradient is the change in y. I'm just going to write a triangle for this. That means changing. So change in y over the change in x. What I need to do is I need to find out how much does the y value change by, and divide that by how much does the x value change by. Sometimes people do rise over run. What I'm going to do is I'm going to select 2 points on the lines. I'm going to choose 0, 10. I'm just going to go up to this point here as well. 10, 40. What's the change in y? Well, I've got 40, take away 10. What's the change in x? Well, my x value here is 10 and my x value here is 0, so it's 10 take away 0, which is equal to 40 take away 10 is 30, 10 take away 0 is 10, 30 divided by 10 is 3, therefore my gradient is 3. Now that I've got my gradient and I've got my y-intercept, I can write out my equation for line A, which is y equals 3x, because that's my gradient, that's my m, and my y-intercept is 10, so therefore it's going to be plus 10. Now if we look at line B, I've got my y-intercept, which is 50, therefore C is going to be 50. I know my gradient is going to be negative. What I'm going to do is I'm going to take the point here at 0, 50. I'm going to take the point here. Now you choose 2 points to find out the gradient. You just need to make sure they pass through an exact coordinate, but it doesn't matter where you take the 2 points on the line. As long as you do it correctly, you will get the right answer. Now remember, the gradient is the change in y over the change in x. Therefore, so gradient is equal to, right, I'm going to look at this point here. So my gradient is, my y value is equal to 0 here. And at this point it's equal to 50. Therefore it's going to be 0 minus 50. Remember, because it slopes downwards, you know that this gradient should be negative. So if you work out the gradient, it's not negative, you know you've done something slightly wrong. I'm going to go to, and at this coordinate, the x is 5, and the x value at this coordinate is 0. Therefore, it's going to be 5 minus 0, which will give me minus 50 over 5. Well, minus 50 divided by 5 is minus 10. Therefore, I know that my gradient is minus 10 and that my y-intercept is 50. If I want to write out my equation, that would be y equals minus 10x plus 50. So just remember, to find the gradient, pick 2 points on a line, then measure the change in y over the change in x and between those 2 points. And remember, if it slopes upwards, the gradient is going to be positive. If it slopes downwards, like line B, then the gradient is going to be negative. In this equation, what they've done, they haven't given us the line, but they've given us a gradient, and on the graph, they've shown us a point which the line passes through. And if I look at point P, then the coordinates of point P are 4, 3, xy. If you have a gradient and a point which a line passes through, you can find out the gradient of that line. I'm going to put the gradient in first because that's minus a half. That's what, and remember, if you're looking at a straight line, the gradient is what m is equal to. Y equals, the gradient is minus a half x plus c. I've got my gradient, but now I need to find my y-intercept, and we can see that point P is definitely not the y-intercept because it's not where it passes through the y-axis. But what point P does tell me, it does tell me that when on this line, that when x is equal to 4, that y is equal to 3. And that's really helpful because what that means is I can substitute in the values 4 for x and 3 for y in order to find out and then I'll be able to work out what my C value is just by solving the equation. Well, if we look at this coordinate, we've got x equals 4, y equals 3, so I'm going to put those values in, and that'll give me 3 equals minus a half times 4, which so it'll be 4 over 2. Well, minus 4 over 2 is minus, I've got 3 equals minus 2 plus c. And all I need to do is now solve it, so I'm going to add 2 to both sides. And that gets me 5. Therefore, my C value is 5. So my answer to the question is y equals minus a half x plus 5. If you're given a gradient and a set of coordinates, insert the gradient into the equation in place of m, and then substitute your values for your x and y from your coordinate point, and then rearrange to find your value of c. And once you've done that, you can just write out the equation of the line, because you've got your gradient and you've got your y-intercept. In this question, what they do is they give us 2 points. So line D passes through points minus 3, 5 and 2, minus 10. Find the equation of line D in the form y equals mx plus c. This time we haven't been given the gradient and we haven't been given the y-intercept, but we've been given 2 points on the graph. And what I'm going to use these 2 points to find is the gradient. Sometimes some people like to write out the gradient, do a little sketch. Doesn't have to be accurate. Okay, 2 minus 10 would be 2 on the x minus 10 down here. So that would be one of the points, 2 minus 10. You don't have to do this sketch, it's just if you find it easier to do it this way. Minus 3, 5. Okay, I go to minus 3, I go up to 5. It'll be somewhere around here. It's not, I haven't done it to scale, of course. And 5. And from this graph, you should notice that the gradient of the line is definitely going to be negative because it's sloping downwards. When you're using coordinates, you always take one coordinate off the other. It doesn't matter which way around you do it, as long as you do it the same way around when you calculate and you change in y over the change in x. Otherwise, you will get a mix-up in the sign. As we said earlier, the gradient is the change in y over the change in x. And if we look at our y values, they're minus 10 and 5. And what I'm going to do is I'm going to do this coordinate, take away this coordinate. So I'm going to minus 5 from minus 10, and I'm going to minus 3 from 2. Therefore, I'm going to get minus 10, take away 5. I'm going to have 2 minus 3. That's a double negative. And that means my gradient will be, well, minus 10 minus 5 is minus 15. And my change in x is 2 minus minus, that's going to be a plus, because it's double negative, 5. Therefore, my gradient is minus 3. Now that I've got my gradient as being minus 3, I can insert that into the equation y equals mx plus c, m being the gradient. And that verifies that the gradient, yes, it is negative. I'd know there was something wrong if it wasn't. But I still need to work out my c value. And if you remember from the last question, I've got 2 coordinate points, and they tell me the first one tells me when x is minus 3 that y is 5, and the second one tells me that when x is 2, y is minus 10. Now I can choose either of those two, it doesn't matter which one I choose, but I can use those points to substitute the values of x and y into the equation and find what my value of c is, or what the y-intercept is. I'm probably going to choose the second equation because it's got quite an easy x value. X is 2, y is equal to minus 10, but if you use the other coordinate, that's perfectly fine too. Right, so I've got minus 10 equals minus 6 plus c. I'm going to add 6 to both sides. I'm just rearranging it. Well, minus 10 add 6 is minus 4 equals c. Now that I've got both my value of x and my value of c, I can put them both into my equation to give me y equals minus 3x minus 4. And that's my equation of the line. Now, the last question is quite a tricky one. It's, well, we're not asked to find the equation of a line here. We're asked to find the gradient of the line Q. And it says line Q passes through the points A and B and C and D, where A plus 6 equals C and B plus 2 equals D. So first let's think about what is the gradient. Well, we know the gradient is the change in y over the change in x. And how would we do that? I'm not going to put any of this, I'm not going to use these numbers yet. I'm just going to have, so gradient is where it's changing y, so we'll do this equation, take away this equation. Remember, it doesn't really matter which way around you do this. We've got d, take away b. And we've also got c, take away a for the change in x, because we need to take away the y coordinates from each other. We need to take away the x coordinates away from each other in order to get our gradient. But this doesn't help us because we don't actually know what the numerical value for d and b is, and we don't know the numerical value for c and a. But if we look at the equations they've given us, we've got an equation that links d and b together. And what I can see is actually I can rearrange this to get b equals something in terms of d. If I minus 2 to both sides, what I'll get is I will get b equals d minus 2. And because d is the same as d minus 2, I can actually put it in here. So what this will give me is it'll give me the gradient is equal to d minus 2. You do have to be very careful when you put these values in. I've also got this equation here where I'm going to minus 6 from both sides. I'm going to do the same with a and c. And this gives me a equals c minus 6. I'm going to put those values in as well. So instead of writing a, I'm going to write c minus 6. And what this gives me is I'm going to have d minus 2. So it's going to actually be a plus 2. And on the bottom I'm going to have, I should have put that in brackets. I'm going to have c minus c and c minus and minus 6, which is going to be a plus 6. Remember, double negative. So do remember you do need to take away both the 2 and the 6, the minus 2 and minus 6. And because it's double negative, that's why you're going to get a plus. And you can actually see from this that the d's cancel each other out, the c's cancel each other out, and you're left with 2 over 6. And this can be simplified if you divide top and bottom by 2 into a third. Therefore, our answer, the gradient of line Q, is a third. So with this type of question, you just need to rearrange these equations to get rid of some of your b and a values, and then work it out, and you end up with a third. Thank you for watching. Hope you found that helpful. For more, if you want to see more videos, please smash the subscribe button. And for practice questions, visit the website www.mitchellmathsandscience.com. The link is in the description.